Morning, Emily. Oh, thanks, Luigi. Emily, I think you're
I
muted.
am. I muted my own self. Like I didn't know how to do this. Okay. Thanks for that. All right. So I am so happy to present Jim Dehner, who is talking about his top 5 building blocks on the journey from spreadsheets to Tableau. Now, Jim looks like he's floating right now. I love it. I love the background behind you. But in addition to being floating around, he's also known for floating around the Tableau community. But he's also known for his broad Tableau knowledge. He's a 4-time Tableau Forum ambassador. He's literally helped thousands of Tableau community members. His professional career, he's focused on retail and consumer products industries. He's done product lifecycle management, forecasting, inventory control. He was a business lead on SAP and Oracle ERP implementations. I mean, such a wealth of knowledge. He was a business team lead. I've already said that. He's got a passion for helping students and new users discover Tableau, and that is evident when you see everything that Jim does. He's a frequent user group speaker and has presented at the DataFam Community Jam, and at VizConnect, and was awarded a Vizzy for the most technically sound. And he comes to us from Nashville, Tennessee. Jim, take it away.
Good morning, everybody. I'm going to share my screen now. Okay, I think everybody can see my screen now. Couple things before we get started. Take a moment during my presentation to send a shout out to Emily and to Caesar and to Alex and to Sarah about the great job that the Fringe Festival has done, not just the last 2 days, but over the past year. I found out just the other night that the community jams were attended by more than 30,000 of us users. That's absolutely phenomenal during this past year. I want to talk to you today about my journey going from really an Excel background to Tableau and some of the problems and some of the things I bumped into along the way. But before we get started, I'd like you to think about where you started. You know, where were you when you first started using Tableau? Were you a student? Maybe you were a new hire on a new job, or maybe you've been doing data analysis all your life, and it's just very natural for you. Well, I can tell you where I started, and as Emily mentioned, I'm an engineer. I am not a data scientist, and I don't have an IT background. I'm not a system analyst or anything like that. Actually, I'm a marketing manager. And I had a client that came to me, and he said, "We want you to learn Tableau because we're going to use it for reporting. And don't worry, it's just like Excel. You'll pick it up, and there'll be absolutely no problem." When I started using it, and I got to tell you the truth, I struggled with it at first. There were quite a few obstacles in my way, and I want to share some of that with you. As I look back at it, there were 5 things that I needed to really understand before I was comfortable using Tableau. And I want to take you through those 5 things today, and I want to talk about them at kind of a high level. I will tell you this: there's going to be after the first of the year, we're going to do a deep dive short course into these. But I want to talk about these 5, and the first of them is data structure and data connections. I don't know about how you grew up, but when I grew up in my household, there was always a calendar on the refrigerator. And I could look across the columns on that calendar, Monday, Tuesday, Wednesday, And I can look down the rows and see the weeks. So I can see in cell C3, sure enough, I got a dentist appointment on Tuesday afternoon. Information in a cell, go across the columns, go down the rows. Well, when I started using Excel, I felt very comfortable with that. I've been doing that sort of thing all my life. There's columns, there's rows, there's information. That's wonderful. Well, I started using Tableau, and all of a sudden I found out that Tableau doesn't like data that way. It doesn't like a wide, short format. What it likes is a very tall, very narrow format. So now, whenever I get a data set that looks like this, where all the measures are separate like this, it's a pretty good indication that the data is not structured properly and it has to be restructured. This looks like my calendar. A lot of rows, a lot of columns, very few rows. This data needs to be pivoted, and we need to pivot the data. And to do it, there's nothing more than just highlighting all the cells. And this works with most data sets, not all. Pivot the data. Now it's in a form that we can use it. And you'll notice when I did that, the dates got changed to first of all, they got changed to a string, and the name became pivot field names. I'm not going to change that. I could change it right now, but for use later, I want to leave it just as it is. We're going to change these back to dates. Going to drag it on to the viz. And the pivot field values are sales. So I got sales by month by customer, exactly what I wanted. That was great. And then I remembered, oh, I've got to add quantities to go along with the sales. Well, if I was doing this in Excel, I just use a VLOOKUP. I take a VLOOKUP from the first sheet and look at the second sheet that had the quantities and just bring the quantities over to the first sheet. And I'd have sales and quantities in both columns. I started looking for a VLOOKUP in the Tableau functions. Well, there isn't one. So fortunately, or the way you would do this in Excel, or the way you would do this in Tableau, is by joining the two sets of data together. Joining the data is really a very easy thing to do. We just take the file that we're going to join, drag it on. There we go. Drag it on to the canvas, and Tableau is going to form a link for us. Well, let's open that up, and the first thing it's going to do is it's going to link the common name, and it says, "Oh, I got customers in both data sets." Well, that's where we must want to join. But we also know that it's really important that we don't just join the customers, but we have to look at the dates and get the dates to line up so that we have the sales on a date match the quantities on a date. And we can close that now. And now, sorry. Now we have both sales by month and quantities by month. We have both sales by month and quantity by month, and I'm sorry I've loaded in too much information here. Got sales by month and by quantity by month, which was what we wanted to achieve. And that's great. We can move along, we can do our analysis. And this was fine until I got to the end of the month. In the end of the month, I had a whole new data set that I had to connect back into this data. Now, if I was doing this in an Access database, I would just bring the data into Access, and then I would append the two data sets together. But in Tableau, there's no append command, and you would accomplish this by creating a union between the two data sets. To create a union between the two data sets, we can edit the union and add in our second data set. And when that happens, Tableau will add a column for sheet name and table name, and we can use those table names and sheet names to keep our data separate. We've got the 2020 data and the 2019 data. I'll tell you what, at the same time, I'm going to join in the quantity data so that we've got that data in this data set also. And once again, we got to come back, we got to take a look. We want the dates to match up. And we also want the customers to match up. And now we've got our full year 2019 data and our 2020 data. Includes our sales data and our quantity data for the 2 years. Well, at that point, it became apparent joins are used like VLOOKUPs. And a join is going to add a column into your data. Unions are like an append, and it's going to increase the height of that data. Joins and unions are the way you connect data together for the most part. And they get much more complex than this. The way you connect them in the join calculations are extremely important to how that data connects. It takes practice, it takes work, but joining and unioning data is the way to get data into your data set. There's also one additional type of data that we have to consider and how that data is connected. And that's when you have data coming from two different data sources, okay? Or that you have data that's at different levels. Like the example I'm going to show you is we've got data at the year level, and we also have data at a monthly level. And there are two different levels of the data set. Now, for those two types of situations, you need to blend the data. There's a couple things you need to understand about blended data. First of all, blended data always results as an aggregate, and that aggregate takes place at the level of the link. Okay, and also with blended data, you limit the functionality that you have in Tableau. There's some things you're no longer able to do. But let's take a look at a couple data sets here. I've got some sales data. This is sales by year, by quarter, and by month. And I've also got some goals. And the goals are set in this company by year and by category. I can blend these two data sets together. And the primary source here is the sales data. It's the first set of data that was brought to the biz. It becomes a primary source. And the secondary source are my annual sales goals. And we can see the sales, and we can see the goal. But I want to look at this goal for a second. Something's wrong here because we know we'd looked before and we had different goals in 2018 and 2019. Well, let's take a look at the relationships. Remember I said that the data is always aggregated at the level of the link or the join between the two data sets. This data set was joined on category, but we also have to join it on year. Sure enough, when we do that, we have our goals for 2018 and 2019 are different. So we've got three different types of connections that we have to be used and have to be familiar with. There are joins, there are unions, and then there's blending the data sets. Now, I told you before that blending data limits the functionality and the capability inside Tableau. And that's a result of the order of operation. Now, if there's one thing you take away from this presentation, pay attention to the order of operation. It is probably the single biggest cause of errors or problems when you're trying to create a viz. The order of operation is nothing more than the sequence that Tableau goes through in creating your viz. Every program you ever used has an order of operation. And the order of operation is that sequence or that process that Tableau goes through. When you create a worksheet in Tableau, what's actually going on is you start with a data set, and that could be a flat file like an Excel file, or you could be using a dimensional database that could be coming out of your ERP system or some public data source. The first thing you're going to do is you're going to create a dimensional table at the worksheet level. And you can think of that as an Excel spreadsheet, if you will. It's got headers across the columns, it's got headers down the row, there's some filters applied to it, and that is the structure of the table that underlies the individual worksheet. Once that structure is created, you load values into that table, you manipulate the values a bit, you do some math, and then you decide whether you want to see a bar chart, a line chart, or maybe even the dreaded pie chart. Well, the order of operation that you go through is, I like to think of it as 10 steps, but I group those 10 steps into 3 groups. The first 2 steps are extracts filters and data source filters. They operate at the workbook level. They limit the amount of data that's in your workbook. And because there's less data in the workbook, the performance of the overall workbook is improved. The next 3 sets, context filters, the creation of sets, fixed LODs, and top ends in calculations, and dimensional filters create that data set or that data table that you're looking at. It's like putting headers on your Excel spreadsheet for rows and for columns. And then the last 5 steps in the order of operation add the values into that data set. Allows you to do some math. You can add some measure filters. You can do totals, do some table calculations. I want to take just a real quick look at steps 3, 4, and 5, where we're working with dimensional filters, LOD expressions, and context filters. The reason I want to spend a little bit of time here is because context filters are very misunderstood. And we get questions almost on a daily basis. I want to create a calculation that ignores a filter. And I want to tell you, Tableau does not arbitrarily or randomly decide to ignore calculations or ignore filters. You as a developer, you as a designer, decide when you're going to apply a filter. And that determines whether the filter applies to the calculation or not. Now I've got a very simple LOD expression here. I'm going to make that larger so you can see it. And all this does is it says, well, for each type, whether it's fruit or vegetables, for each type, just give us the sum of the total cost. And the total cost is another calculation that just takes price times quantity. Okay. So you can see here, I've got this calculation, and the sum of the total cost is $5.75 for fruit, and the LOD expression applies that just like we thought it would to each row in that presentation. Now I want to come back, and we've sold out of bananas, and I want to take bananas out of this expression. So I'm gonna remove the bananas, and right away we see that the total in the LOD expression has changed. It's now $3.75 instead of $5.75. Well, that happened because produce and the produce filter is applied to context, and it is applied before the LOD is calculated. If we wanted to apply the filter after the LOD is calculated, we would remove it from context, and sure enough, now our LOD returns the $5.75, which is the total. So you decide when you want to apply that filter. Here's an example in using sets. Now this is just a simple set. I wanted to see the top 3 based on the total cost. And the top 3 that are in the set are apples, bananas, and green beans. Okay. And once again, I just used a set here, an in and out set. I'm going to just show you the in set because it makes it a little clearer what's going on here. Once again, I'm going to take bananas out. And when I take bananas out, and we filter after, produce is not in context, we filter after the top 3 are determined, there's only 2 left. And that's because the third item were bananas, and we eliminated it after we calculated the top 3. If produce name were in context, we'd have 3 values. Bananas have been eliminated, so it's apples, green beans, and spinach. you are in control. You as a designer are the one that decide when that filter is actually applied. Okay, we're about ready to move on, and the next thing we had to learn is the language of Tableau. Every system has its own language. And one of the things you learn when you start using Tableau is that a lot of the expressions and a lot of the functions look very much like those in Excel, but they're totally different. When you're using a spreadsheet calculator, when you're using Excel, for example, what you're actually doing is you create a formula and it sits in a cell. And then you copy that cell and apply it across rows or columns to do what you want. In Tableau, in any other database-oriented system, what you're actually doing is creating a calculation on dimensions and measures that apply that calculation to the entire row or the entire column all at one time. The syntax is different, and you just plain have to learn what the syntax is and how to write a calculation. But fortunately for us, Tableau's got a calculation wizard. And for those of you who are very familiar with Excel, this looks kind of familiar. Whenever I write a calculation, even today, I always use the calculation wizard. Okay? You open up the wizard, all the functions that are available are listed. There's a drop-down filter that groups them together to make it easier to find. Over here in this right panel, it explains what the calculation is and how to use it. But most importantly, there's a syntax checker. And as you create a calculation, the syntax is being checked as you enter the calculation. Let's take a little look at how this might work. Create a calculation. I'm going to go to this drop-down. I'm going to open it up, and it says Create Calculated Field. Now I want to create a calculation that is the price. And you can see that Tableau is going to autofill times, and I want all the quantity involved, so I'm going to take the sum of quantity. Okay, and right away we're going to get an error message. And the error is going to tell us that you cannot mix aggregate and non-aggregate arguments. One of the big differences between Excel and Tableau is that in any calculation, all of the dimensions or all of the measures have to be at the same level of aggregation. This is a very simple fix. We aggregate the price, and sure enough, we've got a calculation that's valid and will work now. Now, calculations are the backbone of customizing your analysis and making the analysis do what you want it to do. While it might look like there's a lot of different calculations that you have to learn, there's actually only 4 types of calculations that are 4 types of calculations that you need to look at. There's simple calculations. We just looked at the type where like you sum the sales over sum of quantity and to determine the ASP. But also in simple calculations are the if statement, if you will. And people who write SQL are familiar with this format. It's just very simple. It says, if a condition is met, then perform this calculation. If it's not met, then perform another calculation and. The second type of calculation are date functions. And date functions are very important, and they're very unique. And it takes a lot of learning to really understand how they work. Date functions will return either a date or a reference to a date, or you can do date math with date calculations. The third type are LOD expressions, and I gotta be honest, LOD expressions are my absolute favorite. Those of you who've seen some of the things I do will tell you that I overuse them, I abuse them, I absolutely do. But LOD expressions allow you to create additional layers in your data set. Not back at the data source, but in the data table that underlies the specific worksheet. And then finally, the table calculations. And you ought to feel real comfortable with table calculations because they're very similar to what you would do in Excel. Let's take a look at a simple calculation. We've already looked at the simplest of calculations where we calculated, sales quantity times price. I want to take a look at an example of an if-then statement. Whoops. I'm just going to open this up, make it large so you can see it. And we just got a new vice president of sales, and you know how those guys are. They want to make a change to their organization. And the old guy liked the eastern region and the western region. This guy wants to call it coastal. He likes central to be called middle, so we're going to change that to middle. And then the southern region is just fine. So we can do that with a if-then statement. And the way you would read this, it starts out with if, and then the dimension. If region equals east, or we can use conjunctions here, either or and, or is the appropriate one to use here, or region, and you have to repeat region, equals west, then call it coastal. If that's not the case, else if region equals central, then call it middle. And if it's not either one of those, just call it south. And we get a new grouping. We can pull region out of here. Whoa, Jim, that wasn't very good. Okay. We can take region out of there. And now we're regrouped in the way that the new vice president of sales wants to see his regions grouped together. I want to look at date calculations. Dates are a very important and a very unique type of dimension in Tableau. And I want to distinguish between real dates, and maybe some of you have gotten a response from me when I'd answered a question that you have to be using real dates. Real dates are defined as dates or as date time. Real dates know how to self-sequence, they know how to sort, and most of all, they can be used in date functions. Okay. If we just have a string in there that says year, or we have a string in there that says month, that's not a real date. Let's take a look at this first type of date calculation. And this date function, and I'm going to just sort this for dates so you can see what what other date calculations are available. Date part returns a reference at the level of the date that you're looking for. It returns an integer value. Okay, so date part month, the border date, is going to return a value between 1 and 12. 1 for January, 12 for December. You could also have used date name, which actually returns the name of the month, January, February, March, or whatever. Date name is great when you're going to put labels on in an expression, or you want to put labels on a chart. Date part is very important when you're doing some date math and you want to do date calculations. The second type of date calculation I'm sorry. I'll be honest with you, there we go. When we converted to the new look Tableau, and measures and dimensions got kind of sorted and grouped together, it's still a little confusing to me. I'm sorry about that, but that's just the way it is. Okay, the second type returns the actual date. And date trunc is probably my favorite. Use it all the time. Date trunc returns the first day of the period that you're looking at, either month or year or quarter. And it actually returns it at a date time level, although we're only going to look at it here at the date level. So date trunc month, border date, will return the 1st of January, 1st of February, 1st of March. If this was in here as quarter, it would it would return the first day of the quarter. So if quarter 1 is January 1st, quarter 2 is April 1st, and so on. Date trunc is great when you want to work with year-over-year calculations, period-over-period calculations. If you're trying to do any sort of date range, date trunc is an extremely useful calculation to use for that. You could also use date add. Date add adds an integer or an interval at the level selected in the calculation. The third type of calculation that you can do with dates actually calculates the third type is date math. A date difference calculation or date add. What this calculation will do, it takes the difference in days between the order date and the ship date. We wanted to know how long does it take us to ship a product. So we write a calculation that says, give me the difference in days between the order date and the ship date. And it returns that value. And when I brought it to the viz, I aggregated it with average. So I can see that the average shipping time varies around 4 days, a little above or a little below. Date math takes a lot of work. You have to get used to working with dates. You have to get used to what the different date functions do. My recommendation to you is make yourself a small data set. Work with it a bit so that you fully understand what date functions return a reference to the date, which ones return the actual date, and how to do date math. Now we come to my favorite type of calculation, and that's the LOD expression. If you think about your data when you entered it into Tableau, the lowest level of data that you have, like maybe it's row level invoice data if you're working with an ERP system, very granular, whole lot of data. Think of it as the base of a pyramid. Now, if you aggregated all that data, so it came back with one number, the total sales of everything that was in the data set, that would be the top of the pyramid. Well, what LOD expressions allow you to do is it allows you to select the level that you want the data aggregated at so that you can use it. Now, the beauty of LOD expressions is that while they are an aggregate of data, they are not an aggregate in themselves. And because they're not an aggregate, they can be used in any other type of expression. You can use them in simple calculations. You can nest them inside other LOD expressions. You can use them in date calculations, and you can use them in table calculations. Absolutely, absolutely love LOD expressions. We've been down this road before where we've seen apples and bananas. I just want to show you, and we're going to write a calculation here, create calculated field. The wizard opens up. And I want to write an expression that says fixed, and you'll notice that it's for me, fixed type, produce, whoops, excuse me. I write some sales far too often, some quantity. And close. And I did this so that we could talk about what this expression actually says. In words, what this says is take all the combinations of type and price, and for all those combinations, sum the quantity and store it away so that I can call it up later and I can use it later. Okay? You've created a virtual layer in your data set. It's not back at the data source. It's available for you to use on this worksheet or any other worksheet in your book, but you've created a virtual layer in your data set. And you can have as many of these as you want. I want to talk about table calculations, and then I'm going to show you how we can nest an LOD inside a table calculation. Table calculations, people coming from an Excel background usually feel pretty good about table calculations. And the reason is because you're kind of working on that data table. You know, I told you before that you've created this dimensional table inside for each one of your worksheets. And while it doesn't really look like an Excel spreadsheet, it sure helps, at least it helps me, when I think about table calculations and how they're used. It helps me think about table calculations. With table calculations, we talk about scope, and we talk about directions. Scope is how much of that data table the formula is going to apply to, and direction is which way are you going to apply the calculation. Probably a data scientist would refer to this as a partition, but we're going to refer to it as a pane, and the direction going across is going across the columns, or down is going down across the rows. Table calculations are very easy to create. You just drag a dimension or drag a measure to the marks card, open it up, and you can add a quick table calculations, and a number of them are out there that are already done for you. And we're going to take a look at percent of total. And sure enough, Tableau creates the percent of total calculation for you. We can see here, it calculated it across the rows, or across the columns, an across calculation. That's not really what we wanted. Doesn't make a whole lot of sense to do that. So we can edit the calculation so that now we go down the table, and that's more what we were looking for. Now, if you wanted to use this calculation at another time, you can just drag this off, and you can see here it created a separate measure for you called calculation 2, and I'm going to open that up just so you can see what it says. And I do that because you can, this is the actual formula that's behind that calculation. When you start writing your own calculations, and believe me, you will, you'll write your own table calculation. This is a good place to start. Take this calculation, make it your own, use it inside other table calculations, or use it to do exactly what you want it to do. Now, I told you I wanted to show you how you can nest an LOD expression inside other calculations. Very often we'll get a request where someone wants to take a look at a ranking function. They say, well, I want to know the rank of my subcategories, and I want to know how it changed over time. Let's take a look at this expression. And the way you'd read this, and what this does, it says for each combination of segment, subcategory, in the year of the order date, total the sales. Give me the sum of sales at that level, and then save it in this thing called LOD sequence subcategory sales. Just save it there, because I'm going to want to use it later. Now we can come back and create a table calculation, rank, based on that LOD. We can rank unique, and there's our LOD expression. And you notice I use the aggregation sum because all table calculations are an aggregate. They have to be aggregated. The argument inside the table calculation has to be aggregated. So we're aggregating the LOD expression using sum, and I want to see it in descending order. I can add that to our biz, and I'm just going to hide this stuff away. I'm just going to hide that away so we can look at the actual ranking. And this doesn't look like the ranking that we wanted. Once again, it's going across the columns, and that's not really what I wanted to see. Well, let's open up. And you open up this wizard by clicking on that triangle, opening it up, and you have a number of options of how you want that calculation applied. We're going to go down to specific dimension, and I want you to pay attention to this highlight here. When you click this box, the calculation assistant is going to show you how the calculation is made. Well, we want to look at the subcategory level. And I don't want to look at the entire table. I mean, look at these values here. They get up around 200. I don't want to look at the entire table. I only want to look segment by segment, but this still isn't right. And I want to restart that calculation every year. Now the table calculation is performing like I expected it to. And it's going to give us the ranking by subcategory, by segment, by year. So you can see the phones were first with consumers and corporate in 2016, and third in home office. And by 2019, that changed around. So they were first in home office and consumer, and fourth in corporate. Now that's going to lead us to the last of the building blocks, the last thing needed to understand. And I call this a toolkit, and it's made up of filters, sets, and parameters. And those filters, sets, and parameters are what your user can use to change the look of the div. We've talked about dimension. We've talked about filters before, but I want to emphasize to you that there's a couple of different types of filters. We've talked about dimensional filters. And dimensional filters are applied in steps 3 through 5 of the order of operation, and they affect the structure of the data table. That's where you can change the structure and eliminate data from the data table. There are also measure filters, and measure filters are applied to the values that are in the data. Okay? They don't apply to structure, they apply to values. We'll take a real quick look at dimension filters. You've used these. There's not a whole lot to say about dimension filters. We eliminate office supplies, the structure of the table changes. I want to look at measure filters. Measure filters, on the other hand, apply to the values that are in the table. They're not changing the structure. We're just looking at the values that you see on the screen. Okay? If we want to create a filter on quantity, the first thing that happens is this box opens up. And we take a look at the first entry in this box. It says all values. That entry will apply the filter at the row level of what you see. We could also apply to an aggregate, and there's a number of different types of aggregations we can use. It's not just sum, but you can use standard deviation, variances, mins, and max. But for this purpose, we're just going to look at the row level. We're going to apply our filter, and I want to look at everything in the 1 to 15 range. And sure enough, all the rows here are 15 or less. We could do that same thing, and we could apply it at the aggregate level sum. And now we only get 3 rows returned. We only get these 3 rows returned, where this is aggregated at the row level, or this is filtered at the row level, this is filtered at the aggregate level. Filters remove data from your data set. It's no longer in the data table that underlies that particular worksheet that you're working on. Sets, on the other hand, recategorize that data into 2 groups, the in group and the out group. All the data is still available to use, and it's great for making comparisons. Back in 2019, I think it was 2019-3, set actions were introduced that allow the users to change the composition of that set from the screen. And just recently, I think it was 2022 or 2023, you can now use a set control that looks very much like a filter dropdown, and it allows the user to pick the values in the set. This is just a simple set to create a set here on subcategory. All you have to do, click on it, open it up, create set. That's all it takes to create a set. This particular set has in values in blue, out values in gray, and that's the default. That's what it usually looks like. And as I change the composition of that set, you'll see that we can look at the sales by segment, by region, and how those compare to what was in the set and what was out of the set. And I told you before that these can be nested also. We can include this as a percent of total. And we're going to want to look across the data. So now we can see the percent of total or the share within these different categories. Very useful tool, easy to use. Parameters are the third piece of that toolbox. And parameters are probably the least understood, and quite honestly, a whole lot of users just plain don't want to use them. But they provide so much flexibility to you. Have you ever had a data set where you said, look, I'd like to input one value. I'd like to be able for the user to go to that screen, and I'd like them to be able to input a value, either from a drop-down or to key it in. Well, that's what parameters allow you to do. But you have to understand how they work. First of all, parameters are single valued. They only have one value at a time. Okay? And that value only changes when it's changed by the user. Either they change it manually, or you can use a parameter action to change that value. The value is global. By that, I mean it's the same value throughout the entire workbook. You don't have to use it the same way throughout the entire workbook, but the value is the same throughout the entire workbook. But now here's the key point. They don't do anything. Parameters in themselves don't do anything until they are used in a calculation or a filter. And it's a calculation or the filter that actually does the work. Very simple parameter. We go to create a parameter just like we did on a set, just highlighted, create parameter. And you can create a parameter, or you can make your own, and you can type in a list. And starting a year ago, parameters became dynamic. Dynamic parameters the value of the list can be changed when the workbook opens, and you can have it load from your data set. And you can also, with a calculation, identify what you want the value to be when the workbook opens. This is just a very, very simple region parameter. And right now, it's not doing anything until we use the parameter in a calculation or a filter. And this is just very simple. It says, hey, look, if the region equals the region parameter, this is going to return true. Put it on the filter shelf and set it equal to true. So now when I change the region, you'll see that the data changes appropriately. Well, those are the 5 building blocks that I wanted to talk to you about. And to me, these are the things that I really have to understand before I can become comfortable using Tableau. If you've ever studied mechanics or physics, you bumped into a guy named Archimedes. Archimedes lived in the 3rd century BC. And Archimedes had what he called the 6 basic machines. And he's famous because he said any machine, any other machine can be made of these 6 basic machines. And the machines we're talking about here are things that you learn about. There's levers and there's pulleys and there's ramps. I told you I was an engineer, but it's that level. And any machine can be made from those 6 basic machines. Well, for me, I had to understand these 5 functions, these 5 concepts before I was able to really understand Tableau and how it worked. This is a workbook that I keep around and I use on occasion. And in it, we calculate the year-to-date sales and the prior year-to-date sales, year-over-year growth. These use both date calculations. They use LOD expressions. The date selected here as the starting date is driven by a parameter, and the ribbon that you see at the top is connected to a parameter action. And I've got it set to hover, and you can see that as I change the date, the parameter changes, the starting year changes, and the year-over-year calculation changes also. Over here, this map of the US is a value picker tied to a set and a set action. And with that, we can select the states that are in the set versus the states that are out of the set. And likewise, this market selector is also a set action, and I can select what state that works with. It's all a combination of those 5 basic principles. Well, that's what I wanted to share with you today. The workbook that you saw today is out on my Tableau public site. It's the featured item on my Tableau public site. Go on out there, download it, play with it, enjoy it. If you have questions, please contact me. There's a write-up that goes along with what we talked about today that's sitting out on my blog. and you'll see it out there. My blog is really dedicated to what I call the newbie plus. The guy like me came from an Excel background, and he's trying to work his way up and understand more and more about Tableau. But that's pretty much what I wanted to talk about today. That sort of sums it up, Emily. Are there any questions?
There are no questions right now in the Q&A box. I would encourage everyone, if you have questions, go ahead, pop them in there real quick. So that way Jim has some time to answer them before we bring on our next speaker. But yes, I'm seeing a lot of good reviews, great jobs, so good. Sam was like, I'm definitely will recommend this video to lots of people. So, and a lot of rewatches that are going to be taking place, I know for sure.
Okay, well, thank you for your time today. I really enjoyed it. And thank you, Emily, for allowing me to speak today.
Of course, I love the 5 blocks, or the 5 building blocks. It's perfect to help people get into Tableau.
And just to share once again, after the first of the year down here at the Nashville Tug Group, I'm going to be doing a short series where we're going to take a deep dive into each one of those blocks.
I think that's awesome. All right. Thank you so much, Jim. Again, everyone, please give Jim a shout out on social media using his Twitter handle, which is Market Analytic and the number 5 and hashtag TFF2020. Let him know what some of your takeaways were, so that way other people can also see the impact of Jim's talk today. And with that, we're going to take